Illustration number 8. The series combination of resistance in omega and capacitor in Faraday is connected to an AC source of V volts and angular frequency omega. If the angular frequency is reduced to omega by 3, the current is found to be reduced to 1/2 without changing the value of voltage. So we have to determine the ratio of capacitive reactance and resistance. So first of all, I have considered my analysis by this assumption. IRMS as a simple I and VRMS as simple voltage V. So the value of I and V are related by this equation. I is equal to V over the value of Z, and here the value of Z is only in terms of R and C because there is absence of inductor. So such kind of idea you have to apply by just study the statement of illustration. So here R square plus 1 over omega square C square, and therefore if I multiply or I am squaring this current, therefore I square is equal to V square over R square plus 1 over omega square C square, but 1 over omega C is the value of XC. So it is equal to V square upon R square plus XC square. So this is the square of the current. In the second case, this was the first case. Now, the value of omega is reduced to omega by 3, and hence the value of current is now become half. So it is I by 2, and therefore now I can apply to this equation. See, I am taking first of all this equation number 1, this is my equation number 2, and so from equation 1, instead of I, now I am writing I by 2 is equal to V over under root of R square plus the value of 1 upon omega square C square. But here, if you see, the value of omega is changed to omega by 3, and hence now I can put directly the square of this omega by 3, that is omega square by 9 in this value. So here the idea comes 9 upon omega square C square, and now also here I am squaring on both the sides. What I will get? Therefore I square by 4 is equal to V square over R square plus 9 over omega square C square, but 1 over omega square C square is XC square, that is equal to V square over R square plus 9XC square. So that is equation number 4. Now dividing equation 2 and 4, we will get I square over I square by 4, that is equal to V square over R square plus XC square whole divided by V square over R square plus 9XC square. Now see, V square is cancelled. Here I square is also cancelled, and this denominator of denominator will now come into numerator. Therefore 4 is equal to R square plus 9XC square, because it is also the denominator of denominator, and divided by R square plus XC square. Now I am taking this R square plus XC square into the multiplication with 4. Therefore 4R square plus 4XC square is equal to R square plus 9XC square. Now let's get all the terms on one of the side. Therefore here comes 4R square minus R square is equal to 9xc square minus 4xc square, that is equal to 3r square is equal to 5xc square. But your target is to find out the ratio of reactance and resistance. So x square over r square is equal to 3 by 5. But still this is the ratio of square of reactance and square of resistance. So taking square root on both the sides, therefore the ratio of reactance and resistance is xc over r, which is equal to under root 3 by 5. So this is your required equation, and now we will switch on to illustration number 9. Illustration number 9, the maximum value of an AC voltage is equal to 100 watt for a square wave is shown in this figure. So before we move further, you have to consider that which kind of voltage is existing over here. Either it is DC or AC. So actually if you see the full curve, then it is a AC voltage, but till this time interval T by 2, if you consider, then it is almost DC because it is constant and not changing with the time. And so I can write down the RMS value of such voltage with this equation. Vrms is equal to 1 over T integration 0 to T, because here the time interval is shown from 0 to T, V square T dt, and it is raised to 1 by 2 because we have considered the RMS value, that is equal to, inside the bracket, 1 over T, here comes integration 0 to T by 2, V square T dt, and here what is the value of 0 to T by 2? It is 100 volt. So 100 square T dt minus T by 2 to T. So we have partitioned the integration into the coefficient of 2, means 0 to T by 2 and from T by 2 to T. So here we have considered two sections, and the second section is T by 2 from T, and at here if you see the value of voltage, then it is minus 100. So minus 100 whole square into T dt, and the curly bracket is over. And also the box is also over, but don't forget to put the 1 by 2 due to this RMS. And in your textbook there is a printing mistake, they have not written the 1 by 2 value, which is equal to, now let's simplify this, 1 upon T is as it is, inside the curly bracket it is 10 to power of 2 and its square. So the result will be 10 to power of 4 into T dt, means T by 2 dt, or we can say T by 2 minus 0 plus, and here the time interval is taken over here, so you just have to consider integration dt plus, here also minus square will be positive, so 10 to power of 4, that is T minus T by 2. And now the curly bracket is over, box is over, and 1 by 2 is there. Now let's simplify this. 1 over T into 10 to power 4 T by 2 plus, here T minus 2 by 2 is also T by 2, and here both brackets are over and 1 by 2 is there. That is equal to 1 over T. This is actually 2 times 10 raised to 4 T by 2. So 2 is cancelled. This T is also cancelled. And so the answer is 10 to power 4 raised to half. Means 10 to power 2, that is 100. So the RMS value of voltage is equal to 100 volts. And so with this, our illustration number 9 is over. Now we will switch on to the illustration number 10. And after that we will see the other type of theories. Illustration number 10. The medium wave broadcast signal in a radio can be tuned from 600 kHz to 1200 kHz. So here the range of frequency is given to us, in which the minimum frequency is 600 kHz and the maximum frequency is 1200 kHz. Also, the effective value of inductance of an inductor which is connected in a LC circuit, that is 100 millihenry. So you can convert it easily into simple form of Henry by just multiplying 100 with 10 to power minus 3. So it is 0.1 Henry. And you also have to convert this kilohertz into simple hertz by multiplying with 10 to power 3. But we will do whenever it is necessary. And now for tuning frequency. What do you mean by tuning? For tuning, which circuit is needed? We have studied this in the application of resonant circuit. So for tuning, resonant circuit is needed. And so the resonant frequency or the tuning frequency I am writing over here as F is given by 1 over twice pi under root LC. This equation we have obtained in the theory of resonance equation. Now I am combining this equation by arranging such terms. Twice pi f is equal to 1 over under root of LC. Therefore, squaring on the both the sides, we will get 4 pi square f square is equal to 1 over LC. Therefore, C is equal to 1 over 4 pi square f square into L. And now, we can find out the maximum value of capacitor and the minimum value of the capacitor, and with which we can find out the range of variable capacitor, which is the task of this illustration. So, in order to find out the value of maximum capacitance, that is given by 1 over 4 pi square F max square into L. Now substituting all these values is equal to 1 over 4 into 3.14 whole square. F max, maximum frequency is 1200. So that is 1200 into 10 to power. But here, if you want to find out the maximum value of capacitance, then as the frequency is inversely proportional to this capacitor, then we have to use over here the minimum range of frequency. Therefore, F min is equal to 600 into 10 to power minus 3 into the value of Henry is 0.1. So after simplifying, we will get the value of C is equal to 0.7 into 10 to power or 1 to power minus 12 Faraday. Sorry, it is 10 to power minus 12 Faraday, and there is a printing mistake again. in the value of 1, it should be 10. So 10 to power minus 12 means it is a picofarad. So it is 0.7 picofarad. So that is the maximum value of capacitance. Now for minimum value of capacitance C, the frequency should be maximum. So the equation will be 4 pi square, here F max will take place, into L. So again substitute all the values. 1 over 4 into 3.14 whole square into 1200 into 10 to power minus 3 whole square into 0.1. That is equal to 0.176 into 10 to power minus 12 farad, that is equal to 0.176 picofarad. Therefore, the value of minimum capacitance is 0.176 picofarad, and hence the range of variable capacitor is from 0.176 picofarad to the 0.7 picofarad. And remember, this is the range of variable capacitor. And with this, the illustration for all the theories which we have discussed is over, and now we will see the another concept of physics.